In this video, I'm going to be going through the statistics topics for the OCR GCSE Foundation Maths exam. To start off with, we're looking at populations and samples. Now, a population is generally everybody in a given group. So this might be the population of a school, or it could be the population of a town. It doesn't necessarily mean the population of a large area, but it's a certain type of group that's usually of a substantial size. A sample is a smaller group that will be taken from a population, usually because you can't ask everybody in a population, so taking a sample just gives you an idea from a smaller group. Now, a random sample means that you want to have everybody having an equal chance. Random samples can be collected by assigning everybody a number and using a random number generator to pick them. What this means is whilst everyone has the same chance of being selected, that doesn't necessarily mean it's going to come out with a fair sample. And so whilst it's simple and it is random, it does have its own limitations. What we mean by bias in sampling is where we have certain groups that have not been included or represented in the sample. One exam question I went through recently was where the sample was of a load of children from a primary school or a school in general. And so the question was, why doesn't this represent the village? Well, you haven't included any of the older population. And so when reading these questions and thinking about whether it's bias or not, you have to think about whether or not it represents everybody in the population. So next, we're mainly going to look at ways in which you might interpret data from a chart or diagram, or even have to construct the chart or diagram. The most basic ones would be bar charts and pictograms. Most people find that these are straightforward to do. You just have to take care and make sure you're accurate with those. Most understand the simple ideas. Pie charts are what can take a little bit more practice to do. You want to make sure that you are actually figuring out what size each section needs to be by calculating the angles. So since pie charts are based on 360 degrees, you normally will have a number you can work with to get nice sized angles. If you start going decimal, that could be an indication you're going wrong, so check carefully going back over your work. There are multiple and composite bar charts, so this would be where you might have, say, ask people about favorite sport, and then that bar, rather than just being one bar for that sport, it might be split between, say, male and female. And so you've then got a little bit more data to work with. With these sorts of questions, where you're interpreting those charts, you really have to make sure you've read that question carefully so that you are writing down the correct value. Quite often people do not read carefully, and even by missing one or two words, they end up writing an incorrect answer. The final type we're going to look at is time series data. So this is where your x-axis will be over a period of time, and it talks about identifying trends and gives the example of seasonal variations. Now, trends are the general pattern over time, so usually that will be generally things are increasing or things are decreasing. A very common graph is sales over time. So are there more sales happening over time? Is that the case? Or is the company actually finding that fewer sales are happening and there might be a decline? You don't want to look at the minute detail if you're just asked to define or talk about the general trend. Where you will want to go into detail is if there's some data that shows you seasonal variations. So a very common one would be ice cream sales over time, where that time is over the years. And so you'll no doubt find that as you get to summer, the sales will spike and go up, but when you get to winter, they will drop down. And so it's understanding the context and realizing what's actually going on there in real life. Next, we've got a lot of information here about summary statistics and understanding the misrepresentation of data, which is typically through graphical means. So summary statistics, your standard ones are your mean, median and mode, and also understanding about how to find range. So the mean, median and mode, I've written brief definitions here, but you need to be able to calculate those as well as work backwards and solve problems. So there are some questions where you might have some numbers and then you're told the mean goes up by 1 when another number is added, so you then have to work back. It's not always the case of just straightforward, here's the numbers, find the mean. Median is that middle value when in order. You may have two values in the middle, so you would want to go in the middle of those. And the mode is the most common value in a given set of data. When we look at this from the point of view of grouped data, it gets more complex. So you have modal class, which is which group comes up the most. So this will be on the left side of the table. and it will use inequalities typically, and so you want to write that which group had the most amount of data. And you also want to make sure you could get an idea of estimating range, mean, and median. Now, estimating mean, there is a very standard process that uses midpoints and midpoint times frequency. Estimating the median can be trickier, and you might have to find first of all which group it's in, and if you want to get a really accurate estimate, whereabouts in that group would it be. It says about understanding why they're estimates, and that's because in grouped data you don't know every individual piece of data, so you can't get an accurate answer. You want to make simple comparisons between data, and it says about using like for like values. This would typically be means and range for two sets of data. So you might be asked to compare one school with another, and so in which case you would compare their means and compare their ranges. A smaller range typically means more consistent results and is usually the kind of range you're going for. So if the range isn't very big, it means the results don't move a lot from the mean or the middle, so you want to kind of say, well, that's very consistent and close, and it's usually desirable. Understanding the advantages and disadvantages of summary values is how they might be impacted by other bits of data. So one example is the mean. If you have a very large piece of data in there or a very small piece of data, it would affect the overall average. So you'd want to be able to identify that because it would maybe an outlier, which we'll come to in a bit, but also understand that there are advantages to other ones. So median is not affected by a very large value because it will just get crossed out. And the mode is really useful if you're dealing with data that is not a number. So if you're actually looking for the most common color of car, you can use mode, whereas you can't find the mean color of a car, that won't work. Misrepresenting data, so you're looking for clues. Typically in bar charts these questions have appeared where the bars are not equal width. If they are different, you have not got a graph which is representing that data well. You want to make sure that your axes start from 0 on the y-axis. If it doesn't start from 0, that can be misleading. And you also want to make sure that it's going up in equal intervals. If at any point it's not, then again you've got misleading data, and they would be the typical things you want to look for. Next, we're looking at bivariate data, which is typically scatter diagrams. You need to be able to identify the three basic types of correlation, positive, negative, and no, by how the points look on the diagram. You do want to interpret that within the context, so understanding what it means as one value is increasing, the other value is decreasing. The idea of causation does not really come up in the test from what I've seen, so I wouldn't really want to dwell on that. But you will be expected in most cases to draw or use a line of best fit. Now, one mistake I see a lot of people do is they don't draw the line of best fit, and they kind of estimate the result from their own eye. They just look at it and write a number. But drawing that line of best fit is usually worth one of the marks in that question, and it will also help confirm with the marker where you got your answer from. So do ensure you do that. Now, roughly speaking, a line of best fit should have the same amount of points above and below, and that's really about the only condition it has. Some misunderstandings about this is that it should go through the origin. That's not always true. If you had a negative correlation, that line of best fit will not go through 0, 0. And another thing is that it has to go through specific points. So some think it has to go through at least one point, or the middle point, or the first and last point. None of that is true. It just has to approximate the pattern of the data, and trying to keep the points roughly equal above and below means you've got a pretty good line of best fit. The next bit, which is more complex, is the idea of interpolation and extrapolation. So when you've got a scatter diagram, you might get asked to read a value that wasn't in the original table, so you don't have an exact value, and you will have to go up or across to your line of best fit and then read across or down to your other axis. So when you do that, interpolation is if you're doing that within the data you're already given. So if along the x-axis you had, say, people aged from 10 to 20, and you're asked to get an estimate for someone who's 15, well, you can do that. It's in between the data you've got. Now, extrapolation is where you go outside your given data. So going back to my example, if it was people from 10 to 20 years old, an extrapolation might be, well, what about someone who's 25 or 30? Now, extrapolation is what has the greater limitation here, because it's not always going to lead to a result that you would expect. So one example I give my groups is the idea of how tall you are plotted against your age. Now, if we started this from when you're really young up until when you're, say, 18, we'll have a positive correlation. As you're getting older, you will gradually get taller. Now, the idea that this would continue isn't true. So if you went to, say, if you did this up until about the age of 18, when you go to someone who's 30 years old, that doesn't mean they're going to have still got taller. There's a point where you would naturally stop. And so extrapolation leads to this data that may not be reliable. So you have to think about the context and whether or not it's appropriate to use. So that's a rough idea about interpolation and extrapolation. Those words aren't really used a lot in the test, but you want to get this idea about it being reliable or unreliable because of whether it's inside or outside the given values. The final bit to go through in statistics is the idea of an outlier. So you want to be able to identify an outlier in simple cases, which means if you've got a list of numbers, you can spot the number that doesn't match the list. One question I remember was about you had all the ages of people who were on a trip, and one of the ages stood out because it was the teacher's age. And so that was a recognizable outlier. It says, appreciate there may be errors in data from values. So that outlier may have affected a mean, and so in which case that's what it's doing, and they don't fit the rest of the model. And in a scatter diagram, you'll find that there will be a point that does not follow the other points that you've got. So if you've got a nice positive correlation and there's a point that's sort of way down in the bottom right corner or something, or at the top left, it's going to stand out that it shouldn't be part of that data. And so you might get asked to circle it and recognize that it's there. Now that should hopefully have guided you through most of the statistics work, or all of the statistics work that's outlined in the OCR specification, and hopefully you found that useful ahead of your exams. Thank you.